Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. Today we'll be talking about positive fractional base power and brackets with power. Is that all right? This is the 8th law. Remember I said we have 12 laws we're going to talk about in this video series, so we're almost there, okay? So please, you need to review law 7 and law 4 because law 8 is the combination of both of them. So you have to make sure you review previous video, especially law 7 and law 4. And like I said, if you've not subscribed, you have to subscribe so that you can get notifications when I post new videos. Is that okay? So I'm going to go straight into this and let's see what we have. So there are three things to do here when you are solving this question. The first thing is that you have to first apply law 7 first, then you now raise it to the power of n. So you either apply law 7, okay, first, and then raise your answer to the power of n. Or another thing that can happen is that you multiply both powers together, then apply law 7. So for example, okay, let's pick this one. Let's say we have a 1 over m all raised to power n, okay? So like I said, what you can do is that you multiply it first. So it's going to give you a n over m. So let me put it this way so that it will be easy for anyone. So you can now multiply it. So remember I told you that you multiply from law 4. You multiply the powers together. So 1 over m times n, and that will give you a n over what? M. Then from law 7, I told you when you have n over m, it's the same thing as having the mth root of a all raised to power what? N, or you can say a raised to power n all what? The mth root. Okay, so we talked about this in the previous video. So that's why I said it's a combination of law 4 and law 7. Now, if there is a constant, okay, it also applies. It's going to give us a 1 over m times n all multiplied by k, and that will give us k a n over m, and that is the same thing as saying k into bracket the mth root of a to the power of n, or we can say k the mth root of a raised to the power of what? N. The next one is if, for instance, it's n over m. Still the same principle. So if, for instance, we have n over m to x, there are several ways of doing this. It's either you want to apply law 7 first, what I said here. So it's going to be the mth root of a raised to power n, all this raised to power what? X. Are you seeing it? Or you can say the mth root of a, okay, all raised to power n, then all this is then raised to power of what? X. Or another way to do it is that you multiply both of them. So it's going to give us a nx over m. Are you seeing it? Then this will now become the mth root of a all raised to power what? Nx. Are you seeing it? Or you can say a raised to power nx all what? Mth roots. Are you seeing it? So you can see it's a combination of rule 4 and rule 7. So it depends on how you want to do it. Then D, if you have a constant, okay, it's going to be k, the same thing, the mth root of a to the power n raised to the power x, or you can have k the mth root of A or N or X. So it's going to be exactly the same thing, but the difference now is that we're going to have the constant outside the bracket. Is that okay? Or you can say the mth root of A or NX, or you can say you can have K, the mth root of A and X. And that is that. So these are the rules for positive fractional base power and bracket with powers. So let's pick some examples now, okay? Let's solve some examples to explain what I'm just trying to say. So, right, move this one. So we have number 1, okay? We have n, 1/2, 3. Are you seeing it? So like I said, when you have something like this, exactly like the first one, it's either you want to multiply and get this, all right? Or you solve the one in the bracket and raise everything to the power of n. So what we can do, I can multiply. So it'll be 9, 1/2 times 3, and that will give you 9, 3 over what? 2. And this is the same thing as saying 2 square root of 9, all this raised to power what? 3. Are you seeing it? The square root of 9 is what? 3. Then raised to power 3, this is going to give us what? 27. Are you seeing it? Let's pick another one. So let's say we have a coefficient now, okay? 9, 1/2 raised to power 3. So like I said, we'll solve it the same way. We're going to have 2. We'll have 9, 1/2 times 3, which will give us 2 into bracket, 9, 3/2, which will give us 2 into bracket, the square root of 9, all raised to the power 3, which will give us 2 into bracket, 3 raised to the power 3. Now it should give us 2 multiplied by 27, and that will give us what? 54. Are you seeing it? So when you have a coefficient or a constant outside, you just leave it like that. Is that all right? Okay. The next one is if you have, for instance, we have 27. We have 27 all raised to power. Let's put it this way. Let's make it a bit more interesting. So let's say we have 27, 2/3, then all raised to power what? 3. So if you see, I told you when you have x, there are 2 ways of doing it. Either you solve the ones in the bracket, then raise all the answer to x, or you multiply both of them and you apply rule 4, okay? So what I would do is, what I can do is I'm going to solve the one in the bracket. So it's the same thing as saying the cube root of 27, all raised to power what? 3, 2. Then all this now raised to power what? 3. Are you seeing it? So I'm solving the one in the bracket. And that will give me the cube root of 27 is 3. Raised to power what? 2. All this raised to power what? 3. The next one, 3 raised to power 2 is what? 9. Okay. Then 9, all this is going to be raised to power 3. And 9 raised to power 3 is 700 and what? 29. Are you seeing? So that's how you do it. Okay? So you solve the one like this, or you can decide to say, okay, I want to do it this way. I'm going to be 27, right? Let me put it this way. So you can have 27, 2/3 times 3. Are you seeing it? And that will give me 27, 6/3, which is the same thing as saying the cube root of 27 all raised to power what? 6. And that will give you 3 all raised to power what? 6. and that will still give you 700 and what? 29. Is that okay? So you see, regardless the method you use, you will get exactly what? The same answer. All right? Now let's go to the next one. So for number 4, what about if there is a coefficient, for instance? So let's assume we have 2 into bracket 27, 2/3, all raised to the power 3. You see, it's exactly the same thing. So this time I'm going to use the second one, okay? So I'm going to use the second one. So let's say you're going to have 2 into bracket 27, 2/3 times 3. Are you seeing it? Which is give you 2, 27, 6/3, which will give us 2 into bracket the cube root of 27, all raised to the power what? 6, which will give us 2 into bracket 3 raised to the power 6, which will be 2 times 729, and the answer will be 1458. And that's the answer for that. So as you can see, regardless of the method, it's just a combination of rule 7 and law 4. So that means you need to be very conversant with the previous laws, so that as we keep on going, we're going to be playing around with each and every one of them. Okay? All right, so that is that for that. So the next video I'm going to talk about now will be negative fractional powers. All right, so I'm going to talk about negative fractional powers. That will be the law 9. So remember, we have 12 to go, 12 laws. So that means we have about, this is law 8. So we're going to have about 4. So we're going to the 9th law now. All right. So if you have any question with this, or there are some questions you don't understand, please don't forget to reach out. And if you have any concerns, please send me an email. And don't forget to subscribe, so that when I upload new videos, you'll be the first person to know. All right. So I'm going to see you in the next video. We're going to talk about negative fractional power, which is the 9th law.